Hello, I'm Rien Visser, working here at the New Zealand School of Forestry, University of Canterbury, which is located in Christchurch, New Zealand. What I'm presenting here is looking at advancing mechanisation and automation in New Zealand's plantation forest industry. And this presentation was first given as part of an IUFRO Webinar series on automation and forest operations. It was a three-part webinar series with different countries presenting from different industries as well, but mainly focused around forestry. If you want some more information, do jump onto the IUFRO website and you'll be able to find the details from the other presentations, the webinar series there. What we do know is that many industrialized processes are moving towards high degrees of automation, and in fact will transition towards autonomous operations in the future. Forestry is a very challenging environment where to integrate automation and/or autonomous operations. And that's why we're sharing this presentation really as an opportunity to learn from each other. We know that there's many developments in different countries, but also across different industries. And hence that cross-pollination of ideas is where we will get the best results. So our contribution here is really looking at our industry and how we've moved towards very high levels of mechanisation, and as well as look at some of the research work that we're putting in towards higher levels of automation. I'll finish off with just a couple of ideas and developments looking towards the future of how we might carry out our operations, at least some of the ideas that we've got in mind. What I can say is that while I've been directly involved in a number of these projects, I would like to acknowledge that a number of people have contributed directly to this presentation through providing me slides or images of their research work, as well as some details. And I've certainly worked together with a number of people on research projects as well that we've integrated in here. So thank you very much to the people listed here, a few others as well, I'm sure, but I appreciate their input. For those international guests listening into this presentation, just a little bit on plantation forestry in New Zealand. I think what is of note is that we've got relatively large pine plantation estates. Majority is pine, about 90% of our plantations. And the way that it's managed is in these 25 to 28-year rotations. And at the end of that rotation, we'll have a clear fell harvest, and then the area is planted again for that cycle to restart. So in this image here, right in the background, you'll see our native forest, and our native forest is not harvested. So we focus all of our forest management on our plantations. In the back there, you'll see some new areas just recently planted. In the middle there, some forests that are growing, and in the foreground, you've got a harvested area. In terms of the harvesting systems that we do work with, they're very varied, typically broken down ground-based, as well as cable logging operations. But you can see here an image of a cable logging operation. We do have a lot of steep terrain. About 40% of the harvest areas are on what we would consider to be very steep terrain, where these cable logging systems dominate. Okay. But you can see the need for infrastructure as well as space to work. And of course, we need to do this in a cost-effective manner, but also making sure we ensure high levels of safety as well as high levels of environmental performance. Harvesting systems tend to be relatively large scale. Again, I'll show you during the presentation how we have achieved high levels of mechanisation, but most of our crews would be harvesting somewhere in the order of about 300 tonnes per day, using 4 or 5 pieces of equipment, 7 to 8 staff members or forestry workers to make up that crew. What is relatively unique perhaps to New Zealand forestry is that much of our product that we harvest from our forests will end up to heading out for an export destination. About 60% of our trees that are harvested are converted into logs that will be loaded onto a ship, as you see in that picture in the bottom right. But of course, we also process timber in New Zealand at our processing plants. Some of that will service the domestic market, but again, much of that will also head off towards our overseas customers. So on the one hand, it's It's an interesting landscape as well as an interesting logistical challenge that we have in terms of making sure our industry is successful. But because it's such an industrialized process, it also provides a lot of opportunity for advanced levels of mechanization and automation, as well as even autonomous and the introduction of autonomous equipment. And one thing we can note straight away is that we've actually moved very, very quickly. Only about 10 years ago on our flat terrain, we were extracting our fell trees with skidders, and we still do that. That is still the primary extraction method. But on our landings, on our processing areas, we actually used a lot of manual labor. So we had people measuring stems and marking them up, and then we would have perhaps 2 or 3 skid workers with chainsaws to buck up that timber. What was driving that particular system design was lowest cost, but also this perception that you get the best accuracy in terms of your cuts and your measurement, and hence the highest value recovery when you actually use people as opposed to machines to carry out these tasks. With regard to our steep terrain operations, again, just less than a decade ago, nearly all of it was people workers, forestry workers with chainsaws felling the timber. Then we'd have our cable yarding systems, but nearly the majority of our cable yarding system relied on having choker setters, breaker outs, we'd call them in New Zealand, perhaps 2 to 3 per crew, working down on the hill, setting these chokers to allow us to extract the stems from the slopes up to that processing area that you can see on the left-hand side. Again, the drivers were that low cost. At the time there, labor was relatively abundant, so we had good workers. There was many workers available, and they were also relatively low cost. So that made these particular harvesting systems very flexible. There's not too many places you can't put a forest worker. A person with a chainsaw can access many parts of the terrain quite readily. So we did enter a decade of change, probably starting about 2012, and it was a very sudden change. 2 of the main drivers were removing workers from risk, so really looking at improving safety, as well as the need to remain internationally cost competitive. So there were some drivers there in terms of increasing the cost of labour, decreased availability of labour, and so we really needed to move towards more mechanised systems to achieve both of these goals. Of course, in our flat terrain, so our extraction was already mechanised, was really a focus on mechanised felling, as well as mechanised processing on landings. And that was relatively easy to achieve because that type of technology was already readily available. We did need some equipment that was suited to our terrain. You can see in the bottom right there, Waratah, relatively famous New Zealand company that's been internationally successful. So we needed the size, scale, capability in terms of this equipment being able to handle the timber, as well as for Pinus radiata, the relatively large branches that we had to delimb, and also dealing with accuracy on stems that were not always perfectly straight. But it was very much driven by our forest industry, the want to change as opposed to a need to change. There's a real desire to change. And so it was moving away from these manual processes to really relying and depending on the technology, in this case, being able to accurately measure as well as accurately buck up the logs that are make up the larger proportion of our export market. What you see here is a small interpine that's originally made by a company called Interpine based up in Rotorua. They call it the Harvest Audio audit video, but it's a really nice example of a fully mechanized ground-based system. You can see the skidder there on the left that's extracting the stems from the forest. And then you've got a couple of machines basically processing, fleeting, and then loading out. Fully mechanized, there's nobody on the ground, perfect solution for our flat terrain. But it wasn't just the mechanization of the operation. One of the real opportunities that you get when you introduce equipment into harvesting systems is that they also become a data management type system as well. So in this case, the harvester heads are controlled by a piece of software called Stand4D. So it's able to capture a lot of information about each tree that is felled and how it is processed. So it isn't just a count of the trees, but it's really also looking at all of the physical size parameters, the diameters, the lengths, as well as the number of logs and the types of log sorts that are actually being cut. In this case, Interpine started it. It's now being managed by a company called Forest PhD. In this case, it's a piece of software called Styx, and it's commercially available. So what Styx does is really not only just capture that data, put it on a server, but it actually processes that data and makes it very useful for the company. So you get your GIS mapping, you get your online reporting. So as a company, you buy into the service and you get a lot of useful outputs from it, which is critical. So it isn't just a matter of knowing where the machines are and what they're up to, but you can actually start to get a really complete picture of all the trees that have been harvested, all the different sizes, and where they are actually placed throughout the forest over time. Again, while that in itself is a good service, there's a real opportunity here also to link harvesting to silviculture. So really going in towards higher levels of use of that data. So we know at the time of harvesting processing, we can collect all of the information from the trees, geospatial location, as well as volumes, as well as qualities. So you can see that in that image down below, it's effectively a thinning operation, but you can see where the trees have been thinned. And this is work from a PhD student of mine, Alejandro, now working back in Uruguay. But you can actually start to generate some heat maps in terms of where you might find the actual volume. So we've got our plantation forests. All the trees are identical. They're planted at equal spacing. So any change in volumes and or quality and or of course dollar values that we might obtain for the products that are harvested, we could map geospatially and actually start to have a look at the differentiation we get across our sites. And of course that differentiation will typically be driven by things like aspect and or soil type. So by feeding that back into our silvicultural system, we're able to get information that we can use in terms of perhaps fertilizer, stand management, or even different planting, or even different species if required so this is a pure output from our cycle that we can use as an input for the next cycle. Mechanization on steep slopes, that was always a bit more challenging. There wasn't that much technology available on the international sphere, and I think this is where New Zealand really has made a significant contribution. So one of the systems that I guess you could say has been very much further developed here in New Zealand is this concept of winch assist. So you can see the winch all the way on the left. So it's a drum with a wire rope on it. It's mounted on a piece of equipment on the left. Again, in this case, on an excavator. It can also be mounted on a bulldozer. But basically that winch, the wire rope, is supporting the felling machine, which you see all the way on the right, moving down the slope. So all of a sudden, with this system in place, we're able to move from having to put people with chainsaws down on the slope to being able to not only just fell the trees, that's where we started, but as we got better with the system, we're also able to bunch the trees for the subsequent extraction, or even shovel the trees, which refers to moving the trees, swinging them either uphill or downhill to the place where we can actually process the trees. So we're moving towards much higher levels of mechanization on steep slopes. I've been able to track the development of this technology. I run a database here, which is looking at costs and productivity of our harvesting systems. And we know now that more than 50% of our cattle yarding operations have winch assist support. And it was interesting that when we first introduced this technology, there was actually a real increase in cost in terms of dollars per ton extracted. But as we got better at implementing these systems and using these systems, now we actually see an increase in production from these harvesting systems, which has actually resulted in an overall decrease in harvesting costs, which is exactly where we want to go to remain internationally competitive. The other part, so that was the mechanisation of the felling. The other place where New Zealand has done a lot of work is looking at the extraction with our cable logging systems. So the image you see on the left there is a typical mechanical grapple on a swing yarder. So that has been readily available already for a number of decades. But almost 2/3 of our cable logging systems were tower yarders, which does not suit the mechanical grapples. So a number of companies here in New Zealand have invested quite heavily in developing mechanical or motorized grapples. And you can see one there in the bottom. And so we're able to now put tower yarders across terrain using motorized grapples to extract, to fully mechanize the extraction process. So mechanized felling, mechanized extraction, mechanized processing on the landing. Again, it isn't just the mechanization of the equipment. These particular carriages have embedded in them camera technology, GPS technology, so that we're actually able to track and monitor progress and to help automate those particular processes as well. In terms of this benchmarking database that I've already referred to, I'm able to track mechanisation. Pointed out this is a decade of change. So if we have a look at mechanisation of felling in front of our yarder operations, that's the grey line in 2012, very low, only about 5%, and now we're getting close to that 50% of all of our timber being mechanised felled. But even if we look at our processing, so ground-based processing, only 10 years ago, about 25% of our ground-based, so skidder extraction or forwarder extraction, was mechanised, processed on the landing, and now we're well up over actually 95%. So it's been a very sudden change over a relatively short period of time. The nice thing about this mechanisation, again, we're learning as we go, is that we're expanding it not just felling, supporting a felling machine, a shoveling machine, bunching machine out on the slope, but we're now also winch assist supporting our ground-based equipment, and that's allowing them to operate on steeper slopes. We know that ground-based equipment is in general cheaper to run than cable logging equipment, so this is just a natural extension of that winch assist technology. The image you can see in the bottom there is a grapple skidder being supported by winch assist. And then the image on the right, it's a study we've just recently completed on a winch-assisted forwarder operation. So we're starting to develop new ground-based mechanized systems using technology that was initially developed for our steep slopes. What are some of the next big things? There's always something else to work on. So I'd like to think we've done a lot in terms of mechanizing our harvesting operations to the point where now our biggest risk to our forestry workers isn't within our harvesting systems, it's actually within our transportation systems. What we do know is a larger number of our truck drivers get injured every year, and one of their biggest risk tasks for harm is actually securing the load. So when they, after the logs are loaded onto the truck, they will need to throw multiple chains up over that particular load, packet of logs as we call it, and then they need to twitch down on the far side. And that can lead to back and or shoulder injuries, or that twitching process, that's a lot of tension on that particular bar that gentleman's holding, and that can flick back up and potentially hurt the operator, the truck driver in this case. So one of the inventions or bit of equipment that's being developed, you can see here at a facility where we're actually, in this case, lifting 6 chains. So the truck driver would put the chains across that particular bar. That mechanism, the orange crane looking object there, will actually lift all of those chains up over the truck and lower them down on the far side. So instead of the truck driver having to throw them all, simply this is pulling them all across and they're just twitching them down on the far side. It's a work in progress, but we are making some progress on mechanizing this process. In terms of exports, I've mentioned that much of our product that we harvest in our forest goes overseas. And we've do have some very manual processes, or we have had some very manual processes in terms of transferring these logs that are coming out of the forest onto our port facilities. So that's the Port of Tauranga. You can see they're exporting about 6 to 7 million cubic meters of logs. So that's a lot of volume. And every single one of those logs needs to be tagged and needs to be scaled. So that job was done manually by people with calipers as the trucks came in, and then that was stored in a database. And of course, that was a very cumbersome type process, and it certainly did not help in alleviating a problem of a larger number of trucks backed up in front of our port, which not only causes traffic congestion, but is a serious delay for our trucking fleet. But interestingly enough, at times we may have a larger number of log ships waiting outside of the port, simply waiting to come in to be loaded out. So our port is really that a place where we really can also apply higher levels of mechanization and automation to help facilitate this particular exporting process. So this is from Glenn Murphy, a colleague now working out of Rotorua as a consultant, prior at Oregon State University over in the United States. And he's done a lot of work together with his colleagues on computer vision as well as artificial intelligence. So instead of manually scaling all of these logs as they come in and ticketing them all, there's a higher level of automation. So now they've got this computer vision systems where when the packets or the trucks come in, there's simply an image made, and from this image they're able to derive not only a count of the number of logs that are on there, but also they're able to ascertain the correct dimensions of the logs, the dimensions that they need for their export sales. There's both a mobile solution, you see all the way on the right there, a lady holding a camera system that she will effectively wave over the back end of the truck to get all the information we need, or there's also a fixed frame solution where a scanner will come down and pick up all the information from the truck as it's briefly parked in underneath that particular structure. We're very fortunate here in New Zealand that we have an active research consortium. It's a combined industry government applied consortium, goes under the name of Forest Growers Research Work, being managed by Keith Raymond. And the current focus is very much on landing automation. So the first tranche of the research work, it's about a 7-year program, was very much on mechanization of steep terrain operations. Obviously, you can see it's been very successful. And about 2 years ago, they've started on this initiative of really having higher levels of automation on these particular processing areas that we have. So you can see in this image a number of potential options, including residue management type systems. We end up with a lot of residues in our processing areas, but you can also see the yarder there. The idea is to have a semi-autonomous yarder. So without operating, you get your smart yarder grapples, perhaps able to identify the stems on the ground and pick them up themselves without needing an operator to sit there every hour of the day, just guiding that particular system. So they are making some progress. There's already a yarder that's being built up in the Whangarei area. It's a modified old American yarder, but basically introducing a lot of new technology components that will allow automation. For example, managing skyline tensions, managing skyline placements, normally a very manual task for an operator. Now the intent is to have that more automated. Specifically on the landing, again, this is a diagram of what some of these components may look like, but obviously as trucks come in, that it's a relatively well-defined workplace, so you could go into autonomous unloading of those trucks. Then you can obviously go into scanning, sorting of the logs, a robotic log sorter, and also quite neat in the bottom right-hand corner, you start to see a concept of an automated truck loading gantry. So instead of that robotic log sorter putting them into piles and waiting for a truck, it's able to start loading up some of these gantries, and as a truck comes through, can drive in underneath, the packet will be put onto the truck and the truck can keep on moving. So a lot of opportunities, a lot of ideas around how to make our harvesting systems more efficient. Looking forward a little bit, this is one of my student projects here at the University, Autonomous Forwarder, and I think it's not so much, this is obviously not a finished product, but this was really a prototype that the students designed and built. And I think that's one of the exciting things about higher levels of integration of technology, is that our young people all of a sudden become a whole lot more interested in an industry like forestry. So in this case, with a budget of only $5,000, they've been able to not only build a buggy, but they've been able to introduce GPS, guidance systems, solid state LiDAR sensors for obstacle avoidance, live stream video feedback, and it's all being controlled by a small microcontroller, small brain on the inside. They also spend some time looking at different forms that the carrier might take for most efficient design. So it is exciting, and I think we will get a lot more autonomous type of extraction equipment. It has been identified as one of the lowest hanging fruit in that we're simply moving backwards and forwards with a machine to extract our timber products from the forest. It also provides this opportunity, once we remove the need for an operator from our equipment, we can actually start redesigning a lot of the equipment. If we don't have to have a cab, if we don't have to have a place for an operator to sit, we can actually make our equipment a lot more compact, actually a lot cheaper, and it's probably going to be more capable on and in our challenging terrain that we have in forestry. Another student project that's going on right now, one of my dissertation students, Perry Hahn, is looking at automating the measurement of sweep. So sweep is one of the quality characteristics that we need to take into consideration when we process our stems into logs. Sweep is really just a bend in the tree. So when we mechanize these operations, all of a sudden we're asking the operator to look at a stem and ascertain the level of sweep. So the diameter length that's being picked up by the harvester head, but just how bent that tree is, the harvester head certainly can't pick that up. So here, using a video camera system, again using that artificial intelligence, able to identify the stem as it comes out. And then by mapping the outside edges of that stem, we can draw a straight line from midpoint to midpoint, and then we can actually fit a function, or that's what Perry's done in this case, fitted a function to look at the center line, and then we can see how far that center line of the log differs from the straight line. And that is effectively our sweep, or the curve of the log. And so this would be done in real time and give feedback to the operator and give them an update on the level of sweep they have. There's also been some really cool ideas that other colleagues, in this case, Richard Parker, and a number of other people who are involved. Richard Parker works at Scion. And so you can see here from a concept drawing on the left-hand side. So the idea is to get tree-to-tree locomotion, so equipment that's able to move through the terrain without having to deal with the complexity of the terrain. And so there have been some prototypes built. You can see the battery-powered one in the bottom there, and they've extended that to actually a unit with a felling head as well. So the idea here is really that this particular machine might be used for surveying. So it's able to walk its way through the forest, perhaps do a LiDAR scan, and will simply do an inventory of the trees. But of course, if it's got felling capability, it would be able to move its way through the forest, and as it cuts one tree down, grabs the next, move its way and fell the tree, or perhaps thin the forest autonomously and work, complete the task at hand. Another real future research project here was, you can see by these two images, two gentlemen here carrying out the task of pruning. We still prune our trees, at least prune some of our trees to improve the value. So subsequent to pruning, you end up with clearwood. So all the subsequent growth of the trees is in that clearwood format. So that's of value to the forest owner, but you can see that this is a very difficult task for these people to complete. So this little video footage here shows a little drone, and it's got a set of shears on the front, and it can actually move its way around the stem and actually cut off those individual branches. So the vision, this is Rien here, as well as colleagues at our computer science department here at the university. The idea is to have a drone, a swarm of these particular pruning drones, let them loose in the forest, and of course over time your stand is pruned at a much lower cost and at a much lower level of physical exertion than if you had your individual workers try and carry out that task. Finally, insect drones. This is a colleague of mine here at the School of Forestry, Steve Pawson, as well as his colleagues working at Scion, looking at mounting basically technology onto insects to help study the behavior of some of our pests, but they've also mounted insects inside of drones and picked up the electrical signals from the insect antenna, and that helps detect the presence of pests in our forests. So really are moving into a microspace that's quite exciting, but also really integrating some of this technology into the natural environment for the benefit of our industry at large. So in summary here, in terms of our forest operations, we've pushed really hard for mechanisation, and we've managed to succeed and have a lot of success in a very short period of time. I'd like to think New Zealand here has made a major contribution in terms of the mechanisation on steep terrain operations, in particular wind assist technology, as well as some of these grapple carriages, and that's allowed for fully mechanised harvesting operations in steep terrain. We've also got a very active research program, and that's creating a lot of new developments. But what's really supporting that is a highly motivated industry. And it isn't just our forestry companies, but we're really developing machine construction type industries to really support these innovations as well. So I'd like to think a lot of this automation is being built into our new equipment. But in terms of true autonomous operations, that's still really very much the next step here in New Zealand. We're not there yet. So with that, thank you very much for your attention. My email is down below. If you have any questions or comments, feel free to contact me.